Hello there and then welcome to a brand new video. This is Hub Beyond Numbers where we learn maths the easy way. In this section we are still on plane geometry and we will be looking at vertically opposite angles, adjacent angles, and then angle at a point. We have to understand it as we usually do, and then we'll solve some questions on it as well. So without much ado, let's quickly look into it. We'll first start off with adjacent angles. So talking of adjacent angles, they are angles that share a common side. You see, so in as much as they share a common side, they also share a common vertex. And then finally, they do not overlap. So you can simply put they are angles that are next to each other. They are angles that are next to each other. Just to illustrate, these two here are two different angles, you see, and they are not adjacent. But if we want to make these two angles adjacent, if we want to make these two angles look adjacent, then it should be something like this. So this being our first angle, this being our second one, they are sharing a common side. You see, and this, instead of these two individual sides they have, they are going to share a common side, something like this. You see, and they also have what? A common vertex. You see, as you can see over here, that is what makes them adjacent. You see, that is what makes them adjacent. But if they are separate like this, we don't say they are adjacent because the conditions are written up there. They do not share a common side, neither do they share a common vertex. You see, yes. So basically, we are saying that if angles are next to each other, then they are adjacent angles. Let's look at what vertically opposite angles are. Talking of vertically opposite angles, we say that what? They are formed by intersection of two straight lines. So I have a straight line here, and then another also over here like this. You see? And then you remember we said angles are formed when two lines meet. So these are two straight lines intersecting each other. Now, there are angles that are being formed. Let me realign this. So for the angles that are being formed, you realize that two of them look the same. So two pair of equal angles are formed, and we say they are vertically opposite. These angles are the first one being this here, and then this. You see, this and then this, we say they are vertically opposite. They are across each other on the opposite sides. Then the second one is this, and then this. You see, yes. So those in white are the same because they are vertically opposite. Those in the blue are also the same, but that of the blue and white cannot be the same. You see, there are other properties that as we go on, you would get to know with respect to this over here. I think some of which we have even looked at already. But I wouldn't introduce that here to make anything complicated. But just note that since these two lines, I say they form an X, then the angles they form opposite to each other are what? Vertically opposite. So anytime you are solving angle related problems, look out for X, shapes of X, and you can always identify vertically opposite angles within. The last concept I would like to introduce is angle at a point. Now, when we talk of angles at a point, they are angles that sum up towards 360. So if you have several adjacent angles at one particular point, then we say the sum of all those adjacent angles would be what? 360. So let me put this point here, and this is our point we are going to build these angles on. After which I draw lines or arms of angles. So this is an arm, and then let me draw another arm. So we have another arm this way. You see, we can draw as much as we want, but the most important thing is they are all emerging from a common point. at a point, you see. So if we sum up all these angles that have been formed, that is, we sum up this angle to this one here, and then also to this over here, we are always going to get 360 degrees. And this is a property you have to know so that you'll be able to solve questions as well. Now, for this first question here, we are using to try or just test our understanding. It says you have to find the value of A. Among the terms we have looked at, which of them do you think is going to be applied here? Now, you should take note that these two angles we are talking about, they have a common arm. You see, they have a common arm, hence they are adjacent angles. In addition to the fact that they have a common arm, they are on a straight line. They are on a straight line. This is our straight line over here. You see, these two angles are on a straight line. And these are adjacent angles on a straight line. Looking at our properties, we said that the sum of angles, or the angle on a straight line, is what? 180. You see, and if angle on a straight line equals 180 and we have two angles, then they are supplementary. So this simply means that angle A plus angle 45 degrees is equal to what? 180 degrees. Then you state the property you are using over there. So we are using the fact that they are what? Supplementary angles, and they are adjacent angles as well. So with that said, now all we need to do is to make A the subject. And how do we do that? So we have A plus 45 being equal to 180 degrees. So our A is then equal to 180 degrees minus the 45. And if you evaluate that, you are going to get your A to be equal to 135 degrees. So therefore, the value of A that we want here is what? Actually 135 degrees. And you realize that if you write that here and you sum that up with 45, you are getting what? A 180 degree. So that is it for this question. Now, for this second question here, it looks easy, but you would have to apply certain concepts. You see, so it says you have to find the value of A and then B. Find the value of A and B. So our solution, if you take a look at this you have here, you realize that the value of A and then B, if we take out this line and then this line, let me change its color and make it look like this. What do you see? It is an X. You see, it is an X. Hence, you have formed a vertically opposite angle. So two pair of vertically opposite angles. And where are those angles? We have this and this, and then this one here, and then this one here as well. You see, so that simply gives us the A right away. You see, so we would straight away say that A is equal to 80 degrees, even without solving. You see, then you put into bracket, you write the property you are using, that is vertically opposite angles. So you write that nicely in a bracket. So we got our answers from the fact that the angles are vertically opposite. Hence our A is 80 degrees. Now let's look at our B. Sorry, I initially didn't draw the complete question. You should take note that these angles we have here are not drawn to scale. What do I mean by they are not drawn to scale? This you see here is not, if you are to measure, it might not exactly be 80 degrees. You see, but we are writing them there just to give us the idea of what we are solving. You get it? Okay. So you don't go and measure expecting you get the angle, but then you apply the properties. So how do we get our B? Initially, I said that there are two pairs of vertically opposite angles. That is all of this here and then all of this over here as well, right? But in addition to that, if you take only this line here, it's a straight line, you see. And we said sum of angles on a straight line gives us what? 180. So that simply implies that if we were to add the 80 degree to B and then towards 20, we are expected to get what? 180 degrees. And what property is that? That is angle on a straight line. So angles on a straight line. So with this equation now, all we need to do is to make B the subject. Once again, the most difficult part, or let me say, the only part you need to crack your brains is trying to identify the properties that would help you get your answer. The rest is just algebra. You see, the rest is just algebra. So our 80 plus B plus 20 is giving us 180. And making our B the subject, we can say we have 80 plus 20, which gives us 100. So 100 plus B is equal to 180 degrees. So making our B the subject, it simply means our B is going to be equal to 180 degrees minus 100 degrees, you see. And hence our B is equal to what? 80 degrees, you see. Another question could have been asked that if this is C, what then is the value of C? You see, so if this here is C, you should know that the whole of C here is vertically opposite to all of this. You get it? So it implies that our C is equal to our B plus the 20 degrees because they are what? Vertically opposite. Hence, our C would be equal to the 80 degrees plus 20 degrees, and our C is what? 100 degrees. Irrespective of the question that has been asked, make sure you identify a property that is going to help you arrive at your answer. That is the most important thing. Let's solve one last question that relates to angle at a point. Okay, so for this question here, we have to find the value of x in the figure below. And you'd have to look at it, as I've always said. Identify the property that associates with it that can help you solve your equation. So what we have over here, you can't use angles on a straight line, neither can you use right angles. But one thing you do see is all these lines are pointing towards a fixed point, you see, and that is angles at a point. Now we know the sum of these adjacent angles at the point equals 360. That is a property that comes to mind. So the sum of the angles equals 360. So it means if we add all of this together, if we add all of this, we should get 360. Hence, you write down our equation, and that is 2y plus 20 plus y plus 30, then plus 7y should be equal to 360 degrees. And what property is that? Angle at a point. So now that we have been able to use this property to get our equations, we then do what? Solve. So we open the brackets so that we have 2y plus 20, then plus y plus 30 plus 7y, giving us a 360 degrees. Then you group your like terms. So you have 2y plus a y, then plus 7y, plus your 20 plus 30 should give you a 360 degrees. Simplifying further, 2 plus 1, that is 2y plus y plus 7y should give us a 10y. So 10y plus 20 plus 30, that gives us a 50, should be equal to 360 degrees. And making our y the subject, what do? We have 10y being equal to 360 minus your 50. And 10y then gives us 310 degrees. So what do we get as y? We divide both sides by 10 so that this here cancels here. Then have your y being equal to 31. You see, so this here is the value of y, 31, and that is all. And what property did we use? The angles at a point. You see, so basically this is how we work these angle questions. As I've said, always make sure you identify the property in the question. In this video, we've looked at angle at a point, vertically opposite angles, and adjacent angles. So here are some questions you can try your hands on. You have to find the values of the variables in the following. So this is the first one here. You have to look for x, and then you look for a, the value of a, and then the value of b as well. Then for this, you just look for the value of z. Then we come here, that is questions in a word problem form. Two lines intersect and form angles measuring 55 degrees. You have to find all other angles. And take note, since there are two lines intersecting, then 4 angles are going to be formed. So you have to look for all those angles. Just apply the properties. If there's anything, you can let me know at the comment section. Then this here says angle A and then B are adjacent and form a straight line. Now, if the measure of angle A is this and then that of B is this, find the value of x and then find both angles as well. I do hope this lesson was illustrative enough and then you do understand. This is how Beyond Numbers, where we learn maths the easy way. See you in our next episode where we look at parallel lines and then transversal. Then the angles that are formed because of this nice and fascinating properties of parallel lines and then transversal. Stay safe and stay blessed. Bye.